I'm Mark Barrett. I am the lead game programmer for Tales of the Shire, working for Wētā Workshop. Tales of the Shire is the Lord of the Rings life sim. You play as a hobbit. It's lovely. We're working for Wētā Workshop. Workshop's historic focus has been in making physical things for film, but has more recently, in the last 10, 15, 20 years, branched into a variety of areas, including museum design and tourism, and now video games as well, which is delightful. On March 25th of 2025, we'll release Tales of the Shire onto PC, consoles, and mobile. We at Workshop are crucially only developing for PC. Our porting effort is being done by partners in the UK. They're porting to everything else. So they have to worry about all those more challenging consoles with actual physical distributions and stuff. We only have to deploy to PC. And so that's what going to be the context for this talk, or part of the context for this talk. We're developing the game in Unity. That's also quite crucial to a lot of the conversations and considerations here. And we're using Git as our version control. CI. CI stands for continuous integration. The internet defines this as the process of merging code changes into a primary code base as often as possible. So conceptually, ideally, you have one commit to main and your default branch, and that yields one build, one automated build that other people can play with and see. You can determine for any given commit if you've broken the build, if you run through automated testing and so on. Yeah, you can get useful reports as to what's going on. We haven't done a lot of the automated testing stuff. We've got a little bit, but not a whole ton. Yeah, you may do better in that regard. Continuous deployment, that is more of a thing for other applications that need to push through versions really rapidly at big organizations where they have a much larger sort of automated test suite. They're able to deploy automatically to push to the public. We don't want to do anything like that. It's not at all appropriate for games in general. It's certainly not appropriate for us. So we don't worry about it. So. If you are a very small studio, the question might be why should you bother with CI? The advantage is you have a lot of builds that you're generated, and they're dedicated. They're from a sort of location that doesn't do anything but make builds. You aren't making builds locally on your machine, so you're not corrupting your build process with anything that's unique to your particular machine. There are real advantages to that because it reduces the sort of phenomenon of things just working on your machine and not on other people's. And they're always, the build process is the same thing over and over again. It always happens correctly, and it doesn't require any active intervention from someone who's overworked or doing something else. If anything's broken, as I said before, it's identified quickly and with transparency as to what has gone wrong. And it's a really good framework. It's a sort of great foundation for hanging other stuff off of. I mentioned automated testing. That can go a lot of ways. But there's also like benchmarking. You can run things through a sort of benchmarking suite. We're kind of close to closing that particular loop. You can deploy. I talked about other consoles. You can deploy to other consoles easily, so that it's easy to get things onto a particular piece of hardware and run the stuff on there. It's really a prerequisite for most everything. It feels like to me, everything that's sort of automated, anything that wants to reap the benefits of automation sort of has this as a foundation. So there are other talks that you can attend that will engage more seriously with the merits of CI, whether it's a good thing or not. For me, CI is as fundamental as source control to build games, to develop your game adequately. So I'm a fan, is the short story. Our requirements just to go through our requirements for what our CI solution looks like. Because we use Git, and Git has this sort of lightweight branching structure, it's really cheap to make branches, and it encourages you as a framework to rely on branching as a way to separate out pieces of logic. That really shapes our requirements. Instead of our CI solutions needing to operate on a per commit basis, they get to operate on a per branch basis. Builds don't need to happen on every single commit, but yeah, every time you push to a particular branch or a set of branches, then we'll make a build off of it. So the primary target branch is main. Main we sort of means for us our sort of shared leading edge of development, the hottest area where most development is happening at any given moment. So as you ship a particular milestone, main will sort of change from meaning the deliverable for that particular milestone to the next milestone at some point in the proceedings. You'll just sort of fork off a branch that's targeting your particular milestone either when you ship or immediately before, immediately after, whatever. And main sort of throughout becomes the target for where people are working the most. The rest of, and when you perform that branch, that's an example of a reason why you would then create a new secondary branch that you're also looking to make builds off of. So you have a submission candidate branch that you make for that particular milestone, and that submission candidate branch becomes a target for your CI system, or for our CI system. Yeah, you can also, another really common use case is if you're not confident that your particular feature excuse me, is going to work well for, is going to work well in the wild. If you want to see, oh, how does this work in a build as opposed to just in my editor, then you're able to, make a build. You just designate, hey, I want to test this particular dev branch, and you're able to make a build off it. Excuse me one second. So yeah, you don't need to run, again, you don't need to run a build every single commit. There are a lot of commits to go in, especially in Git, but you need to, every time a commit's pushed and one of these target branches is eligible. We had a situation, this is a sort of nice to have, but we had a number of machines that our IT department was decommissioning that were old, but not that old, and so still quite useful. They were just standard Windows desktops, and so it was very desirable to see if we could just utilize those as they were heading for the scrap heap. And we need some way of visualizing configuration and test results and assets in a clear and accessible way. The first solution that we used was Unity Cloud. That sort of shows up on there. Unity Cloud is an offering by Unity. You're able to just integrate your particular project in Unity with Unity Cloud, and it does a lot of it takes a lot of the pain out of the CI. Once you do some fairly basic and quick configuration, you're able to get things up. It's not particularly expensive, think hundreds of dollars as opposed to thousands per month. It's reliable, it was extremely reliable, really comprehensible UI. It was a really appealing solution in a lot of ways. But for us, the non-starter was that with about 30% of our overall planned asset count in, and things not yet segmented into addressables, which add a certain layer of complexity and time, builds were taking about 2.5 hours. There's no right answer to how fast a build needs to be. Builds will take as long as they need to, but faster builds are a lot better than slow builds. And once you have a CI solution in place, you should be evaluating on an ongoing basis how to make the builds go faster. And the prospect of 3 to 4 hour builds, which is what we were looking at when we scaled up to a fuller set of assets, was not. It just wasn't workable. It was it's unenticing, I say, but it was not acceptable. So we needed to find another solution. I'm going to go on a bit here about an analogy that I really fastened onto, and I apologize about. You've heard of the phrase "no muss, no fuss." This is a really hot marketing slogan from like 1954. So I'm separating out the notion of muss and fuss. So the thing that I'm suggesting here is we'll talk about muss, which is things that are messy, versus fuss, which are things that take time and effort. Again, I really fastened on this, and I apologize for it. So how we go faster. One thing that's really striking in Unity, and was striking as we went through this process, is that if you make a build locally in Unity, that process is way faster than Unity Cloud. And this is also true if you're just building an editor. Your iteration time for a particular build goes much, much faster. And it's an annoying fact when you're looking at 2.5 hour build times. There are a lot of reasons for this, but the biggest one is because of this library directory. Unity, as part of its interstitial collection of assets, will build things into a library directory and then only rebuild those assets within that directory on an as-needed basis. So that thing speeds things up dramatically because you only are changing what you need, and it relies on the stuff that's already there. You already have a cached copy of things that have been built in your local file system. Unity Cloud is, however, built on a stateless solution, and statelessness is this important concept for cloud computing in general. The notion of things are sort of clean, and then that's your baseline foundation, and then from there you are able to perform the same process over and over again. You always get the same result. That's called idempotency, and it's a big deal in DevOps. I didn't include a slide or a snapshot in here from the Unity Dev Days a couple of days ago, but they basically talked about builds often go wrong for a number of reasons, and it's sort of built right into the build process that things can go wrong because this is such a frequent and somewhat disposable process. You care about a build very much for about a day or two, and then after that you're not very interested in that particular build anymore for the vast majority of cases. It also is quite error prone, and so really striving for idempotency didn't seem like it was as important for our particular use case as it is for most web solutions, most cloud-based solutions. So if you compare the two solutions, then sort of, conceptually at least, if you compare the Unity build process, when in editor and locally, versus versus stateless solutions in general, you can have one of either muss or fuss. You can either have, with Unity Cloud, you rebuild everything, so that's the no muss solution with lots of fuss, and then you have lots of muss, which is you have all these local files that are potentially corrupt, but most of the time they're not, and it makes the process go pretty quick. And so we figured that if we embraced a little bit more muss into our build process, things would go much faster. Just to sort of follow on to that point, just for a moment. I think CI's requirements in general are well serviced by cloud-based IaaS. This is me sort of justifying the title of this talk, that I'm not, to warn you against sort of going with cloud-based infrastructure as a service solutions in general for building for games in particular. CI, it's well, but it looks like it fits well on paper because it's a hardware-intensive build process. It needs to be run 10 to 50 times a day, but rarely or not at all outside of working hours. You have the sort of virtualized hardware that you don't need to actually maintain locally. So if things go wrong, you don't care. It's not your problem. It's the problem of your provider. But because you can't count on that consistent hardware, you don't have any option to maintain this build stuff, the stuff that makes Unity builds run faster between each run. So Unity Cloud's problem is actually a problem with any cloud-based offering because none of them sort of have this notion of we can just throw away statelessness, we can throw away clean builds, you can just sort of start from an unclean place. They're not built that way. Caching data somewhere is of course a possibility. This is something that lots of cloud-based solutions are familiar with, but then the business case sort of starts to fall apart because cache data needs to be hosted somewhere. It should be somewhere local, and ideally it should be free as well. Neither of those things are cloud-based solutions are very good at. Again, they sort of care about virtual hardware and also things being sort of intermittently available. And once you're done with it, you don't need it for a while afterwards. So, this sort of notion of self-hosted CI solutions. So these are things that can build systems in general. CI solutions in general do like this sort of stateless notion, but they are built around that same statelessness concept. But they are nevertheless sort of available. It is possible to make messes with them and to start from a messy place. But the requirements for kicking off a CI solution are a bit intimidating. There's a lot to do. You need to register hardware. You need to make it run a build agent that engages on either a commit or on a command. It needs to report somewhere. It needs to migrate a build artifact somewhere else. It needs to virtualize hardware configuration. It needs to cache off the data that we've been just talking about caching. There's a lot to do. So there are software for build solutions that really help with this process. This is not a unique problem of Tales of the Shire. The classic solutions have been Jenkins and TeamCity. Jenkins, at least, is I believe, I'm pretty sure, open source, and so free. That's fantastic. But I had some experience with Jenkins, and it's fine, but it was just sort of time-consuming to configure the first time around. So GitHub Actions was a possibility, it felt like, for us to evaluate. Because it was a commercial product, it's a relatively recent product, it's well-maintained, and it was adjacent to it. We were already using GitHub for our hosting solutions. I sort of hoped that it would mean that we had lower initial configuration costs. It would be cheaper to set up in the first place than Jenkins would have been. Lower maintenance costs certainly than Unity Cloud, and then greater reliability than Jenkins, because Jenkins again sort of had weird edge cases and stuff like that. Your maintenance cost, I found, was a little bit higher than I wanted. So yeah, there's more to say about sort of giving a postmortem later on, but basically these goals have been met. But it's definitely not a trivial thing to set up. CI is valuable, but it is it's also cost efficient, but it isn't free. And so there needs to be a fair bit of effort put up front. What we have found, I believe, is that it's faster to set up and cheaper to maintain than Jenkins or TeamCity would have been. Just a quick moment to appreciate a colleague on this front, sitting right there, in fact, Stephanie Linke of Dolphin Ridge Games. We brought her in as a contractor to work on this stuff. She's the author of the solution that I'm talking about today. She's not crazy about public speaking, or else she'd be giving this talk. She describes herself as a full-stack Unity developer. She is extremely experienced at back-end development in general, so this was right in her wheelhouse. But she's also done a lot with server-side work and analytics. She's really talented, though, at everything you throw at her in the game dev stack. If you need to make your game better and you need to do it in a hurry, contact Steffi. She's on LinkedIn. She's everywhere. You can just talk to her afterwards. All right, let's talk a little bit about how we did this. So inside GitHub Actions, there are 3 types of builds. There are scheduled builds, which happen every night. There's a sort of cron job. Let me see if I can point this stuff. Yeah, there we go. This is the schedule thing. It says schedule, helpfully. It's a cron job where you schedule that at 1 o'clock in the 1 o'clock in the afternoon UTC time, which is 1 o'clock in the morning our time. We execute a build every night. That is a clean build as well. So it does actually get down to the sort of baseline. I am interested in reaping the benefits of utilizing the library over and over again, but I am aware that it does go bad occasionally. And so cleaning out the contents of our main branch at least every night is appealing. There are also just manual builds. They're called workflow dispatch, and these inputs here are sort of settings that you can feed to the manual builds. So you basically request these through a page within the GitHub Actions page, and you can set things like, is this should this be a clean build? Should this be a build for release? We have some Odin. We integrate with Odin and have some validation tooling in there, and so we have a build type where we're just able to just run that. And then finally push, which is just defined in a single word up here, but that's really GitHub Actions' killer app, is being able to, it's the same thing with TeamCity and stuff. It's not unique to GitHub Actions, but it is really well implemented and smoothly implemented. It's some of the stuff around us that it represents some of the biggest time savings from developing in Jenkins and so on. You run a build job on every single push to every single branch, interestingly. So anytime there's a push, you have the potential to run a particular build or attempted build, run a series of build jobs, which we'll go through in a sec. We're assuming that there's hardware available for it. There may be more stuff that you can put here in the config for this line, but we just filter on a little bit later. We put in all the logic outside of this particular configuration line, and really it's this push flow that's the primary focus for the rest of the talk. The other two are relatively straightforward and a sort of subset of the functionality that we'll cover in the push discussion. Right, so this is the big stinking diagram that sort of shows the whole kit and caboodle. So over here we have you as a developer, or me, not me, I don't develop anything, but my colleagues as developers. They will make changes to source code in their repo and then push those changes up to Git. That much should be extremely familiar. To GitHub, to Origin. Then there is the GitHub Actions application and framework running on their own servers. That contains a series of web pages where you're able to configure the builds. You're able to say things like, oh, I've done this cute thing where our build machines I name after dwarves. I don't actually do this in real life. I come up with really creative names like Build Machine 1 and Build Machine 2. But for the purposes of this talk, they're all dwarves, so that's nice. So yeah, anytime you see the dwarves, those are build machines. They're down here. So yeah, we map here in GitHub Actions between machines and then the branches that they service. We'll have a look at a page like this a little bit later. And then we have just a sort of centralized log page that sort of shows what the status is of all the different builds that are in progress. Also, I'm sorry, of historical builds and so on. This is the one that shows things that are potentially in progress. It'll just show you the status of each of the build machines. And then there's the setting I mentioned earlier for how you set up manual builds. You can just kick off manual builds from a particular page. You can go from main, you can go from any branch you want, and then you can apply settings like was in that previous config file. You can say, do you want it to be clean, do you want it to be a release build, and so on. On the back end, they have, I assume, this is all black box, but yeah, there's presumably all this data sort of being stored. So you have a mapping from branch to machine that'll sort of say, okay, for a particular branch, that means I should check with this particular device. And then it stores the settings for the manual build, the config stuff that we looked at earlier. And finally, the app that actually runs on here. So it monitors the repo for these pushes. Anytime any branch is pushed to this repo, then it will kick off a job, and it will also look for the scheduled jobs. It will respond to pushes, to manual builds, and so on, all the things you'd sort of expect this server-side app to do. The build machine, then each one of the build machines is running this the client app. It also has a copy of the repo down, which contains the contents of this build.yaml. This is this config file that sort of is in our source, but it also communicates with the GitHub Actions, both the server side and the client, how to actually do its job, what its jobs are. We'll have a look through a fair bit of this file in a little bit. It'll be a lot of fun. Steffi also created this sort of set of scripts that were editor scripts that are inside our Unity project that are run from command line by and large, but they basically interface between the details of our particular project and the needs of our build and the commands that come in from GitHub, from GitHub Actions rather. So this is just a sort of glue layer that binds up various concepts within Unity that say kick off the build and set things up properly from within our project. Yeah. The special sauce that we have sort of added here is this cached repo snapshot. So this is basically at the end of every build, we will send off this, we'll copy off the contents of the source code and crucially all these library directories and the object resources and so on that were built as part of the build. That happens at the end of every build, and at the beginning of the following build, it comes back over and it becomes the baseline for the clone. We'll go into this in a bit more detail in a second, and yeah, then the GitHub clients, the client app is the place where the jobs are actually run. So we sort of define the sequence of jobs, and yeah, we go through this whole sequence. So that is actually what the next. Oh, and then over here we have our sort of locally hosted network drive. This is a sort of standard shared drive that many workplaces will have. This is where we stick our build artifacts, and then from there, both QA or test can get a hold of these artifacts, and other stakeholders like marketing and your publisher, the people who are paying you money, whatever, can get a hold of them as well. So we'll just run through, basically go through these sort of jobs. So this sort of tells you, this little box will tell you what step in this process we're on, and then I'll sort of run through, yeah, what each one of the steps in here goes, just to go into a little bit more detail here. So again, we sort of start with the most familiar bit, where as a programmer, where you make a change and you push to your local from your local client into origin. That process then bounces over here to the server app, where the monitor responds and finds any available piece of hardware. It then refers down here to the config file. This step here is a little bit vague to me. It's not clear to me if this. if the server defers the execution of everything to the particular build machine, or if it runs off of its own notion of what the config is. I think it is probably the latter, but it's helpful to think of the build machine actually just executing its own copy of the. It's more straightforward to me in any case. Anyway, there's this specification inside the build file that it sort of gets ready for. It goes back up to the API to get information like, what is the mapping for this particular machine? Sorry, I should have said at the beginning. The stuff that we're running here is we should check if this particular branch, if this particular push should run a build, and that will come to where's the configuration here? Yeah. Is the branch any one of these branches that's listed here? Should we kick off a build in that case? So it basically goes over here eventually to check and see if there's a corresponding key to this bit, and then if so, then it will come back down here to the config and check, take that variable. It will set these values. Workflow should run. It will set that to true if it finds a thing, and if it does, if it should run, then it sets this runner label field, also inherited from the value here of this little dictionary, then the server app just sort of says, okay, I'm done, I'm ready to go, and we move on to the next step, which is we've determined that we should make a build, and so we start by just notifying our Slack, notifying the CI channel. Github Actions has a pretty good integration with Slack, so the client-side config has this built-in Slack integration. We just go off and hit the API that calls with Slack, and then we notify Slack. The next step is that we restore the cached workplace. So we look to see, we do, in an earlier step, we have secretly sort of cleaned out this clone. This is another sort of GitHub Actions built-in feature. They also, again, do value cleanliness to builds, but we just sort of say, nah, we're going to take our messy stuff from last time and shove it over here. Obviously, if there isn't anything here, if this is the first time we're building this particular branch, then there's nothing to pull over, and we just move on to the next step. But yeah, that's about what's going on there. Is we just copy all this stuff over as a starting place for the contents of our local clone of the repo. Then we actually communicate with back up to origin. I think we might secretly go through the server app, but it doesn't really matter. Again, believe it or not, GitHub Actions has a pretty strong integration with GitHub itself, so it's pretty easy to just go up and say, hey, give me the latest contents of the repository. But it's crucial to note that we get the benefits not only of all these lib object things, but we also sort of start from a baseline of the source code. So all we're doing here is locally copying between. We move as fast as we can onto an SSD, as opposed to having to get all of the data over the air every single time. So this checkout step is much more rapid because it's only dealing with the diff from the last time this branch was built that we start off from here. So not just the sort of build step, but also the this checkout step, it benefits from retaining the information from previous builds. Then we run the build. This is in terms of this diagram, this is not a very exciting step, but because it just goes off the configuration and calls this thing. We'll look at what's going on in here a little bit more in just a bit, but basically all the logic we defer into these Unity-specific scripts, and the call from GitHub Actions is quite straightforward. Hello. Nope. There we go. We then, send the build over to the network. Once the build is finished, everything went fine. It took an hour and a half or whatever, but now it's done. And so once it's done, then we say we pull a little bit of information. We probably have it locally actually, but conceptually we're getting information about the build number and so on from the server app, and then we copy that over into the build artifacts. We then, come on, you can do it. Maybe not. I've been told I need to be firm with this thing. There we go. So we then go from GitHub Actions into just again, pull some more information so that we have a more readable piece of text that we can then send up to Slack about the build being finished and all the commits that are involved and so on. And finally, the last two things, we take a little bit more information, not, again, we're caching this information, not actually hitting the server every time, but it's, again, information like the build number that we query off of the server app and then send back to Origin in the form of a tag. We just tag the revision that we've just built and say, hey, we built a build with the number so-and-so, leave that in a tag. That's great, that gets you a lot of tags. Most Git clients, modern Git clients, handle a lot of slashes pretty well so that you don't expand all the tags that you build. But yeah, we have, I want to say like tens of thousands of builds at this point. So tens of thousands of tags. So finding a way to sort of compress those in your local Git client is very useful. It hasn't been a problem for us, but yeah, your mileage may vary. But the tagging is really useful to be able to see in your Git client thereafter to link back to what build it was that was associated with a particular commit. And then finally, yeah, you do the magic step here where you just sort of take your now completed build and copy its entire contents into this cached repo snapshot. I neglected to mention this isn't actually connected at all to Origin. It's just a pure copy of the contents of your drive. So I don't think we do very much filtering on this. You could theoretically, exclude some files from this copy process, but we just sort of take it all, as I recall, at least these targeted directories. Yeah. Let's have a look at some code. This is inside, we talked about the sort of build configuration files. This is the major build configuration file for this, for this whole process. It's stored, by the way, in a directory called .github/workflows in your repo. That's how it's easily shared in all these locations. It's sort of a known convention thing. Let's see. So there is an example here of this is again the step that checks and sees if the particular job should run. So you can see that it runs on a self-hosted thing and it runs on Windows. We'll look at another step in a minute that this basically, because there are no other restrictions on this runs on any piece of available hardware. And so anything that's available that can run this job can and does immediately. So you have this sort of weird situation where the first step of this build process is run on one machine, and it will then tell the process which machine it should actually run on. It might be the same machine it ran on, but it often is not. So you have these sort of two sequential sections in this build.yaml that may be run on different machines. These are the outputs to the process. So this is, again, this Boolean as to whether or not the workflow should run, and then this label is to say which machine should be running the thing. And then this is, this is a little bit more that sort of runs into this particular command. You can see, this is just, it's not as important to see what this is doing, but you can see we're kind of dealing with, one of the downsides of GitHub Actions is that you're dealing with quite nested language. So the fundamental format of this file is a YAML file, so you're putting these different lines in, but then you run PowerShell commands in here, and they then may also be connecting with, they may have formatting details that some third service cares about. So in this case, you're hitting an API, the GitHub Actions API, and so all this sort of nesting means that your formatting gets quite messy and arcane and somewhat of a pain to debug. Steffi was resilient in the face of adversity with this stuff. We can do it. Maybe not. Good. Okay, maybe just need. There we go. Yep. So this is the rest of the build, just checking if the build should run step. So yeah, we sort of go through. We see if the if the thing is a scheduled build, then we throw in this thing that we add this nightly name onto the label. We are that way able to distinguish scheduled builds from main builds if we ever want to run them in different places. And then through this whole for loop, this is again in PowerShell. So it's complex PowerShell that you're dealing with in addition to being stored in YAML. You're sort of looking for if this label exists in the dictionary that you've just downloaded, and if so, then you say that you found your runner, and the runner name is this thing, and those are the variables. Then you export. Let's see, down here I think. Oh no, this is just the print line of those things. But yeah, you print line. Yep, we didn't find anything, or we didn't find this label, and so we're just not going to do anything. But then if you did find something, then you actually just kick that information out and move on to the next step. You've cached these variables locally, and the rest of the build.yaml is going to depend on them. Okay, maybe. Let's see, I don't know if there's a mouse or something else that I can use to do this instead of. I'm not sure where the. Say what? Okay, great. Are you able to advance slides? Can you advance slides? Could you advance slides? Oh, brilliant. There we go. We got this one, but I might just call out for you if we have this problem again. This is on to the next. This is into the actual build step. It's actually in the same file. It just is a different format because, or a different tool, because there's a lot more looping possible in this one. Or you can see mostly the sort of length of the command that we send into that ci.cs file. This is all the data that we pass on to via PowerShell into the Unity command line. Again, you sort of have this nesting aspect of things. Yeah, but this is really this command here is the thing that actually makes the build happen. And that's the extent of it from a build.yaml perspective. So yeah, that's representative of the handoff into Unity proper. Yeah, I think the rest of this. Oh yeah, then at the end of this, this next step is the copy of the build result into our shared location. Yeah, there we go. That's better. This is the ci.cs file that I mentioned earlier. So this is just inside our main repo directory. Yep, we sort of run through. This is I mentioned the sort of Odin validation, but this is much more classic C# and just editor code that fires this stuff off. Is there anything that's Yeah, this method goes on and on and on, so I won't go through the whole thing at all. But yeah, we sort of run unit tests, we run Odin validation, but this is just purely straight out of our code base. And yeah, we switch between different build types. We look for this configuration dictionary that does a lot of similar things. We have these different types of this is the Unity notion of like, is this a clean build or whatever that we go off of here. This is the actual building section of the CI scripts. So this is, again, I think still in, yeah, this is still in ci.cs. We refer here to, we still have obsolete references to cloud build in our code base, but this is basically, these are basically the commands that this prepare for cloud build and build player that actually execute the build steps from within Unity, and that's a much less interesting method. But yeah, that's how we actually connect into Unity's calls to run the build itself. Yeah. This is what Github Actions, the sort of workflow page looks like. So this is describing yeah, what's going on at a given moment. So you can see here 3 different kinds of builds, although they're really just build jobs. The top one, this is a branch that didn't have a build built off of it, so the build lasted for all of 18 seconds, and we just sort of, we go off this commit, we saw that this branch wasn't listed as one that we needed to build, and so it just ended. This is a main build. This one would have made a build. It lasted for 40 minutes. I've spoiled the end of this slide. This is it worked. Is the short story. And then this one here. This is a dev build that did actually. This was labeled by someone as wanting. They wanted this particular branch to make a build, and so this build took an hour and 10 minutes. That's likely because it was a first-time build, so it took a little bit longer. But that said, variation from build to build is often fairly high for reasons that we don't fully understand. Could I get the next slide? Thank you. Yep. The mapping from, this is new of runners settings. I think it's good that I really carefully type check this. Yeah, This is like the mapping from runners to build names. So I said this is like the equivalent of Dori, Ori, and Nori. This is our very creatively named first build machine and our second build machine. You can see this is the one that has main on it, and then a couple of other optimistic dev branches. Build 2 is more representative of all the sort of dev branches that you tend to accumulate over time. These are similar to dev branches in general. If you need to do a cull of them, or they just sort of build up like barnacles. They don't do a lot of harm, but yeah, they just sort of get untidy over time. As you can see, various features that we've worked on in Tales of the Shire. Let's see. This is what our CI channel looks like. This is what things look like on Slack. So yeah, it will tell you a little bit about, this build was successful, and we failed all of our Odin validations, which is pretty commonplace, but it will show you the results and then commits that were included in this particular build, which is super useful for QA. Yeah, that was a painful feature to get out, but really, really much appreciated. And let's see. Could I get next slide? Thank you. This is finally the list of any individual build. So what a particular run looks like. So these are all the steps that sort of went inside it. You can dig into each one of these, expand them, and find out information on the details of what happened in there. Next slide, please. So yeah, we're still using this thing, so it's not really dead, but in a sort of premature way, we'll have a postmortem on if this actually worked. Next slide, please. The question about whether this worked, whether it did what we wanted, it did definitely work. It met all requirements, plus our build times are much shorter. Builds now with the full game's worth of assets take between 20 and 90 minutes. They're pretty reliable. Spurious builds are in the sort of 10 to 20% range, and are generally sorted by really straightforward fixes like clean builds. Unity Cloud is fairly cheap, but Github Actions is considerably cheaper, provided you're already hosted with GitHub. But that comparison really is sort of a red herring. The length of it would take 10 times the length of our project to make back the time that that Steffi's work cost us in the initial configuration of this thing. But the time difference, the difference between a build that takes on average 45 minutes and a build that on average takes 3.5 hours, it's almost impossible to express how that almost. If we had stuck with our previous solution, I'm not sure we would have shipped the game. It's that dramatic an effect because it just slows down everyone so badly along the way, and a bad build is absolutely catastrophic for you if you have a much slower build frequency. Yeah, this has been an absolute game changer, and it's been crucial to our success. Yeah, it has been an adequate platform for other initiatives. Yeah, some automated testing and Odin validation. Again, we are limited in our integration with those things. You may be able to do more. Yeah. Was this the best option? It was not quick to implement. It probably was faster than Jenkins Team City, as I said before. A sort of sneaky gotcha, though, was that it isn't particularly portable. As we look to future projects, we realize, if we aren't in exactly the same configuration with GitHub, we lose all this code. This doesn't translate anywhere else. So that's one thing. It doesn't sort of move particularly well from project to project. And one desire, the sort of next thing I mentioned, that you sort of want to continuously evaluate, hey, can we make this build any faster? Can we make this automated build process any faster? The next thing to work on is speeding up checkouts. And if your Git repository is hosted in California or some awful place like that, then you can only go so fast if you're living in New Zealand. And speeding up that step would be conceptually not difficult to do. We just need to host the Git, our origin locally. But you would, and there is an option to do that in theory through GitHub Enterprise. You can host your own instance of GitHub, which sounds great until you look at all the crap that you have to implement to host your own instance of GitHub. The DevOps and IT lift is enormous, and the cost is also quite high. So it was not a very appealing option. But so we sort of lived with that extra little bit of time. But it is annoying. Let's see. I think. Oh yeah. This is. I sort of mentioned the fact that both initial development, maintenance of this, of especially the build.yaml was like surgery with mittens. Like you have a lot of different nested layers going on there, or nested languages, so it made debugging kind of painful. Again, I sort of mentioned we're not quite sure why our build times vary as much as they do from branch to branch and iteration to iteration. Obviously, some commits or sets of commits will have more assets in them and stuff like that, but it seems like it varies for reasons that aren't really clear about that. The hardware pool is a bit limited. The notion of there being an available pool is good, but it means that you have to perform this mapping from branch to a particular machine. In a way that makes perfect sense, because you want to maximize, you want to keep your local, you don't want your branch sort of floating around so that you have 5 instances of the same cached piece of data. You want everything to stay on the same machine as much as possible. But it would not be conceptually very difficult to sort of have a central cache that you could pull from that would be local and still quite fast, and then you would be able to sort of diversify and utilize time a little more efficiently. What we find sometimes is we have one build machine that's doing a lot of work, and there are 3 that are just sitting there idle, and in theory you could sort of decouple those and make parallelize a little better than we have been. It does fail with some frequency, but yeah, a lot of those failures are fixed by just running it again or cleaning it out and running it again. Github Actions, I just said this, but it's scary to undertake, and without that, it sort of puts a cap on how fast your build can go. Just one small fun detail is that at the after we built this and everything was lovely, we were introduced to this thing, Weaver Virtual Studio. As I've said, most cloud solutions are no good for you. This one might actually be okay. This one it looks as though it might be a mature game-specific cloud-based CI offering. It solves a lot of the problems that we have with CI. I have no idea if this will actually work. We may use it for our next project, and if that does happen, then I'll have a sequel to this talk where I talk about how this all went. That is it. What questions can I answer? Yes.
So were you using Git for your art assets as well?
Yes. So we used Git LFS. We had the sort of original art assets were stored in ShotGrid, and there was an instance of that hosted by our IT department. But then they were all exported into the same repository, just using LFS. So we found LFS to be pretty viable for managing binary assets in general. That it took many years for LFS to be particularly well integrated into Git, but at this point it seems like it's pretty clean. It doesn't introduce a lot of errors. So. Knock on wood, but we have had very good luck with it through this particular project.
I still have a question.
We'll go to Tim first.
Did you investigate using the Unity cache server for your library caching at all?
We absolutely use the cache server, and that really does speed things up as well. I should have called that out as something else that we use. It was so essential that I just sort of took it as a given that anybody of any size should be using the Unity cache server. It's brilliant. I will say that we have found, with half of our team being remote, it's quite bad if you're remote. And so figuring out how to mitigate that for people who are especially in places with not great internet connectivity, or not speedy internet pipes, that is an ongoing challenge. But I mean, basically, it means you turn it off for them, or if there are enough people in one place, you get a different instance of the thing. That's just a sort of management layer that needs to happen. But yes, our build server had access to the same exact build cache as the rest of our development team, and that was a crucial speed up for both the build process and our dev team.
Hey, we had a similar journey to you with build times. We're fully remote, so we went Unity Cloud to Circle CI, and we also see on both of those, and it sounds like you have as well, just spurious failures. Like, have you gone very deep on? Because we're just like, I don't know, I don't understand this error. I'm just going to rerun it. Oh, it worked.
Oh, it went away.
Yeah, it sounds like you've had a similar story.
I would say it has been I won't say that it wouldn't be workable, but this situation would be a hell of a lot more annoying if our spurious build rate was any higher than like that 10 to 20% mark. So if you're seeing more than that, that's more than we have seen. But at that 10 to 20% level, again, it's one reason why speeding up is so fast, because we didn't see very many of those with Unity Cloud. But man, when they did, if your build's going to take that long, it's really backbreaking. Anyway, to answer your question, I'm dancing around your question because we're so lazy. No. We basically learned to characterize and recognize whatever it was that it was. It's failing again in this particular way. Let's just run it again. That probably means that it needs to have a clean or something like that. Sometimes there would be other, like we need to reboot the build machine or something like that. But those are the types of correctives that we needed.
Thanks.
More questions?
That's not, you made a note that,
Oh, yeah.
you made a note that all the build machines.
You made a note that all the build machines were affinitized to specific branches.
Yeah.
Was there a reason why you didn't have just like, you obviously had a finite list of important branches you wanted to build from. How come each build machine didn't just have a separate clone of each of those branches?
That's practically where you ended up. Maybe, and I might not be understanding your question, but when you make that sort of mapping, when you make it at Github Actions, you say, "Oh, I want to map this particular branch to this particular machine." Then the next time it runs, it will create that local clone of the machine of the build of the branch on that particular machine, and then it will cache that information off and save it. So it isn't, we keep that sort of coupling. It isn't explicit, but it is just sort of it's implicit by the way that we tie the branch to the machine. But I'm not sure that answers your question.
Yeah, you were mentioning that sometimes one build machine would be churning because everyone's working out of its one branch, and you had idle ones. I was wondering why.
Yes. Yeah. Oh, I see. So every build machine, yeah, they could have a copy of it. We just found that practically the risk of running, say, if we have 5 build machines right now, we're looking to build up 10. We don't want to, for a particular branch, be sort of arbitrary and say, oh, we'll just build this. We'll just take the hit of that first time build thing multiple times for each build machine. If it's built on one machine, we want it to stay on that one machine as much as possible. So we could build a sort of smart preferential system to say, oh, okay, this is going to take long enough that we'll slide you onto a different instance of this thing. Again, we could have a centralized cache. We have not worked that hard. Again, that's not something that GitHub Actions gives us right out of the box, and it wasn't the simplest implementation. And so we just went with the simplest thing, and that has largely proven to be adequate for us, because the lifetime of a particular branch, except for main, the lifetime of most branches is quite short. And so like you'll build 1 to 5 to 10 builds per branch, and then you're done with the branch. So it's not so important that it get widely distributed. Anybody else?
That's all the time we have, I'm afraid, but
I'll
big
be right
round of applause
outside.
for Mark.
Thank you again very much, everybody.